Right now, this exact second, something's passing Earth at 270 million kilometers out, and it just moved sideways. Not drifted, not tumbled from some random gas jet, moved 60,000 kilometers off the course that gravity predicted. And here's the thing that should make your stomach drop. Gravity doesn't push sideways. Outgassing from ice that pushes you away from the sun radially, like a pressure release. This went change direction like something decided to adjust its path. 3I Atlas, third interstellar object we've ever detected, came from outside our solar system back in July, been cruising through ever since. And everyone expected it to do what comets do, brighten a bit near the sun, then fade as it heads back out into the dark. Predictable, boring, except it's doing the exact opposite of boring. It flared. Sudden brightness spike right at closest approach and the color started blue. Normal enough went green. Okay, still within comet chemistry, then turned gold, metallic gold, reflective, like polished metal catching sunlight, and it's been holding that color for the last 6 hours. You want numbers? Alto, that's how reflective something is. Sits around 80%. That's fresh snow. That's Enceladus, Saturn's most pristine ice moon. Except Enceladus is out in the cold outer solar system where ice can survive. This thing's at 1.8 AU from the sun. Warm enough that water ice should be cracking, venting, tearing itself apart from thermal stress. But it's just sitting there, stable, reflective, calm, and Chandra's picking up X-ray pulses from it. Regular pulses, rhythmic. Subaru and the VT caught UV flickering, not random, not chaotic, flickering in hertz-range, cycles per second. That's not comet behavior. That's not ice and dust doing ice and dust things. James Webb got the trajectory data post closest approach, ran the numbers, compared it to where pure gravitational physics said it should be. And there's the deviations, 60,000 km, the largest non-gravitational acceleration we've ever measured on an interstellar object. Bigger than Oumuamou's weirdness. And it happened right after passing Earth, right when it was closest to us. Oh, and where's it going? Jupiter. March 2026, 3 months from now. And the trajectory textbook gravity assist geometry perfect altitude, aligned with Jupiter's equatorial plane, optimized for maximum velocity, boost like someone calculated it. So let's walk through what actually happened here because the data is stacking up and none of the usual explanations are holding together anymore. Okay, context, July 2nd, 2025. Amateur astronomer picks up something moving through Sagittarius. Fast wrong trajectory doesn't belong to the sun. Within days, professional observatories confirm it. 3I Atlas, third interstellar object ever. After Oumuamou in 2017, which was that weird cigar-shaped thing tumbling through that vanished before we could get a good look, and Borisov in 2019, which actually looked like a normal comet and behaved like one. This was supposed to be number 3. Collect data, learn about interstellar space, update the models, move on. Interstellar comets should be straightforward. They come in on hyperbolic orbits. That means they're not bound to the sun, they're just passing through. As they approach, solar heating warms them up, ice starts sublimating, brightness increases. Peak brightness usually happens near approach to the sun. Then, as they head back out, they cool down, dim, fade, predictable curve. We've modeled this. We know what it should look like. And for months, 3 Atlas played along. Steady approach, gradual brightening, everything tracking the models. Observers around the world were imaging it, building up data, watching it creep closer. December rolls around. This is when it passes Earth at closest approach. 1.8 AU. Still millions of kilometers away. Not a threat, just close enough for really good observations. Every major telescope that could point that it was locked on. James Webb, Hubble. Chandra, Subaru, VLT, multi-wavelength coverage, gamma rays down to radio. This was the observation campaign of the year. And then it flared. Not gradual brightening. A spike. Sudden luminosity increase right at closest approach that made every astronomer monitoring it sit up and go, wait, What just happened? Comets don't flare. They don't have ignition switches. Brightness changes in comets are smooth, driven by solar heating, ramping up as they get closer to the sun. This was sharp, fast, like something turned on. Check the light curve data from that night. Steady brightness, steady, then spike, jump in magnitude that wasn't in any model, and it held. Didn't flash and fade like an impact or an explosion, just jumped up and stayed brighter. That's when people started paying very close attention because whatever just happened, it wasn't in the playbook. But the brightness spike was just the opening act. The color evolution is where it gets properly weird. Early observations back when 3 Atlas was farther out near the frost line showed blue coloration. That's normal. Cold ice sublimating carbon monoxide ionized nitrogen give you blue. Comet chemistry 1-on-1. As it got closer and warmed up, shifted to green. Also normal diatomic carbon cyanogen molecules that glow green under UV excitation from sunlight. We've seen this on dozens of comets. Hale-Bopp was brilliantly green. So, at this point, everything's still checking boxes. Weird interstellar visitor, sure, but chemically it's acting like a comet. Then, in the last 6 hours, it went gold, not yellow, not orange like a sodium tail, which some comets develop and which fades quickly. Gold, metallic gold to stained. And it's not emissive. It's not glowing gold because of some chemical emission line. It's reflective, catching sunlight and bouncing it back like polished metal. That albedo measurement 80%, that's not coming from ice anymore. Ice can be bright, sure, but ice this close to the sun is being heated, outgassing, fragmenting. Surface should be getting rougher, darker, more chaotic. Reflectivity should drop as the ice degrades. This is going the other direction. Brighter, more reflective, more organized. And that gold color, that metallic sheen, there's no comet chemistry that produces that. Sodium gives you yellow-orange, and it's brief, a tail that streams off and disperses. This is surface reflectivity. This is structure maintaining coherence under solar heating. Think about what this means physically. 1.8 AU from the sun that's inside Mars' orbit. Solar radiation at that distance is intense enough to sublimate water, ice, crack it from thermal stress, create gas jets that blow dust and chunks off the surface. Every comet we've studied up close shows this chaotic, crumbly, degenerating surfaces. They're not stable, they're not pristine, and they definitely don't look like polished metal. So either 3I Atlas is made of something we've never encountered, some exotic material that stays reflective and stable under conditions that destroy ice, or there's something else going on. Surface that's designed to reflect, coating that's maintained, structure that doesn't degrade. None of these are natural comet explanations. And we're just getting started. Let's talk about the coma, because that's another thing that's breaking pattern. Comet comas, the fuzzy cloud of gas and dust surrounding the nucleus, are supposed to be diffuse, chaotic, irregular. Gas sublimates from random points on the surface. Dust gets carried along. You get this expanding cloud that's turbulent and asymmetric. That's what every comet looks like. That's what Borisov looked like. Textbook diffuse coma spreading out, fading at the edges. 3 Atlas, tight, controlled, concentrated. Observers are describing it as almost aerodynamic, which is an insane word to use for a comet because comets don't have aerodynamics. There's no air in space. There's no design. They're just chunks of ice and rock that happen to get ejected from their home star system and wandered into ours. But this coma isn't spreading like it should. It's contained, organized like there's structure holding it in a specific configuration. And it's not just visual impression. Spectroscopic analysis, breaking down the light to see what molecules are present, shows the gas density distribution is more symmetric than it should be. Normal comet comas are lopsided because outgassing is uneven. Sun heats one side more than the other. You get stronger jets on the sunward side, weaker on the shadow side. Coma reflects that asymmetry. This one's showing symmetry. That's hard to explain with random outgassing. Could be rotation averaging things out. Sure, if it's spinning fast enough, maybe the asymmetries blur together over time. Except we know the rotation rate now, and it's not that fast, it's stable, locked. Which brings us to the next problem. The Muamua tumbled chaotically. Light curve was all over the place, brightness fluctuating irregularly as this elongated thing spun end over end with no stable axis. That's what you expect from interstellar debris. No reason for it to have organized rotation. It got kicked out of its home system by some gravitational interaction. Been drifting through the galaxy for who knows how long, tumbling freely. 3i Atlas isn't tumbling. Light curve is smooth. Regular peaks and troughs. Consistent amplitude repeating like a metronome. That's locked rotation. That's a stable spin axis with consistent rotation rate. Objects don't do this naturally. Not interstellar objects that have been drifting through space for millions of years. Collisions, gravitational interactions, outgassing events. All of these perturb rotation. You get chaos, you get wobble. But pull up the light curve from the last week of observations. Peak trough, peak trough. Same period every time. Brightness pulsing at regular intervals as that gold surface catches sunlight at the same angle each rotation. It's like watching a lighthouse. Regular timed, predictable, and not degrading. Over days of observation, the rotation hasn't sped up or slowed down, hasn't wobbled, hasn't shown any of the instability you expect from asymmetric outgassing torques. Comets that outgas asymmetrically, which is all of them, experience torque. Gas jetting off one side pushes the nucleus, changes the rotation. We've measured this on dozens of comets. Spin rates change. Sometimes they spin up, sometimes down, sometimes the axis process. It's messy. This isn't messy. This is control. You could argue maybe it's not outgassing much. So there's no torque except we know it has a coma. We can see the gas cloud and we know it's warm. Solar heating at this distance guarantees ice sublimation. So there's gas coming off. There should be torque. There should be rotation changes. There aren't any. That gold surface flashing at regular intervals isn't random ice chunks catching light. It's geometry, it's orientation. Each rotation, same angle, same reflection. Like the surface is designed to catch sunlight that way. And before you say ice can be reflective, sure, but not like this. Not this stable, not this organized, not this consistent underheating that should be fragmenting it. Which means the interaction surface isn't purely gas. Gas comas don't pulse regularly. They fluctuate chaotically because solar wind is turbulent and the coma density varies randomly. Regular pulses require a more organized interaction. Solid surface or conductive material can create regular patterns if it's rotating through the solar wind in a structured way. The X-rays aren't coming from random charge exchange in a diffused gas cloud. They're coming from something solid interacting with the solar wind at regular intervals as the object rotates. Look at the timing correlation. X-ray pulse period matches the optical light curve period. Same rotation rate every time that gold surface rotates to face a certain direction. An X-ray pulse, every rotation consistent. That's not coincidence. That's the same physical structure causing both signals. Reflective surface catching sunlight, conductive surface interacting with solar wind plasma. Same rotation bringing both into alignment repeatedly. Hubble's high-frequency data confirm the pattern holds over multiple rotations, not just one or two cycles that could be noise. Hours of observation, dozens of rotations, same pulse structure, same timing, same amplitude. This is real. This is repeatable. This is not how comets behave. Then there's the ultraviolet data. And honestly, this might be the strangest piece of the whole puzzle. Subaru telescope in Hawaii and the Very Large Telescope in Chile both picked up UV flickering, rapid hertz-range, meaning cycles per second, not cycles per minute or hour. This is fast modulation. and its regular repeating pattern at consistent frequency. Turbulent dust scatter, which is what you'd expect from a comet coma, produces irregular flickering. Dust particles tumbling through sunlight, different sizes, random orientations. You get noisy, chaotic brightness variations. No pattern, just statistical fluctuation. That's what comet dust does. We've observed it countless times. This isn't that. This is modulated, structured, like something's controlling the UV emission or reflection at specific frequencies. And before you think maybe it's just rotation, no. Rotation period is seconds to minutes for most objects this size. Hertz-range flickering is way faster than that. This is surface feature, structure, something varying on sub-second time scales as the object rotates. What creates regular UV modulation? Rotating surfaces with varying reflectivity. Sure, structured geometry, where different surface regions have different UV properties, but dust and ice don't organize themselves into patterns that create regular Hertz-range modulation. Dust is random, ice sublimates chaotically. You don't get clock-like UV flickering from natural processes. You know what does create regular modulated signals? Active surfaces, systems with moving parts, geometry that's maintained and controlled. Not saying that's what this is, but that's what the signature looks like. Fast, regular, repeating modulation that holds pattern over extended observation. That's engineering signature, not geology signature. And all of this, the X-ray pulses, the UV flickering, the optical flashes, all synchronized to the same rotation period. Multiple wavelengths showing coordinated regular signals. That's not natural comet behavior. That's organized structure broadcasting across the electromagnetic spectrum. Back to temperature for a second, because this hasn't gotten enough attention. 1.8 AU from the sun. Water ice at that distance receives enough solar flux to sublimate actively. We're not talking gentle evaporation. We're talking thermal stress, fracturing, explosive gas release, chunks of ice blowing off the surface. This is violent. This is how comets die. Comet nuclei up close look like nightmares. Rough, fractured, pitted surfaces, jets of gas blasting out from active regions, chunks breaking off and drifting away. They're not stable. They're not pristine. They're self-destructing in slow motion under solar heating. And that process creates the asymmetric outgassing that causes rotation changes and chaotic tumbling. They've guessed Atlas, sitting at the same distance, same solar heating should be doing. All of this should be fracturing, should be jetting, should be tumbling from the torque. Instead, stable rotation, organized coma, increasing reflectivity, surface holding together, no thermal chaos, no ice death spiral. Either this thing is made of something that doesn't respond to heat the way ice does, which would be weird because spectroscopy shows ice signatures, water vapor, normal comet molecules, or the surface isn't pure ice. Coating layer, something protecting the interior from solar heating and maintaining structural integrity. Fresh snow has high albedo, sure, but fresh snow on Earth is cold and stable. Put fresh snow in direct sunlight at this distance from the sun and it sublimates in hours. Gone, eroded. You don't maintain 80% reflectivity under these conditions with just ice. Not naturally. So what maintains high reflectivity under solar heating? Metals, ceramics, engineered materials designed for high temperatures and high reflectivity. Things we use on spacecraft. Heat shields, solar panels, reflective surfaces built to handle solar radiation without degrading. Not saying that's what this is, but that's what the thermal behavior looks like. Controlled, stable, organized under conditions that should be destroying ice structure. And then it changed course. Orbital mechanics are precise. You plug in mass, position, velocity, account for gravitational influences from the sun, planets, major asteroids, and you can predict trajectory to absurd accuracy. We do this for spacecraft all the time. Navigation teams hit targets millions of kilometers away within margins of a few kilometers. Math works. Gravity is reliable. Multiple observatories tracked 3 atlas for months, building up astrometric data. Enough data points to nail down the orbit precisely. Predict where it should be at any given time, accounting for gravity alone. And for months, predictions matched observations. Right on track. No surprises. James Webb got the post-closest approach data. High-precision infrared tracking position measurements accurate to fractions of an arcsec. Compared it to gravitational predictions, and there's the deviation 60,000 clemens. Not measurement error. Webb's accuracy is way better than that. Not gravitational perturbation. All known gravitational sources were accounted for in the model. This is real deviation from pure gravitational trajectory. 60,000 km doesn't sound like much on solar system scales. It's tiny compared to astronomical distances, but it's enormous compared to measurement uncertainty. And it happened right after closest approach to Earth, right at the peak gravitational interaction window, when the object was moving through Earth's gravity well at closest range. Direction matters. Non-gravitational acceleration from comet outgassing pushes radially away from the sun, where the heat is where the outgassing originates. You can model this. Asymmetric ice sublimation creates thrust in specific directions, but those directions are determined by where the sun is. The thrust vector points away from solar heating. This deviation has a lateral component sideways relative to the sun, not purely radial. Gravity alone doesn't do that. Radial outgassing doesn't do that. Radial outgassing doesn't. Lateral course change requires thrust. Thrust that's not aligned with the sun-comet axis requires directional control. MUA had non-gravitational acceleration too, and that was controversial enough. A lot of debate about whether it was outgassing or something else, but most deviation was smaller and could be explained by uncomfortably, but explained by Gaussian models if you tweak roundels, if you weak parameters. This is bigger, less ambiguous, harder to fit into outgassing frameworks, especially given the stable rotation and controlled thermal behavior that suggest minimal chaotic gas release. So, it changed course. Where's it going? Outbound from Earth, now receding, but not just randomly drifting back into interstellar space. Next major encounter is Jupiter, March 2026, 3 months out. And here's where it gets uncomfortable. Trajectory analysis shows the Jupiter flyby geometry is optimized. Not just it'll pass near Jupiter. Optimize precise altitude above cloud tops. Trajectory aligned with Jupiter's equatorial plane. Approach angle set up for maximum gravity assist efficiency. Gravity assists are how we send spacecraft to the outer solar system. You don't have enough fuel to just burn straight there. You use planets. Fly past Jupiter, let its gravity bend your trajectory, and add velocity. If you get the geometry right, you can steal momentum from Jupiter's orbit and boost your speed without burning fuel. Voyager did this. Cassini did this. New Horizons did this. It's standard spacecraft navigation, but you have to plan it. Arrival time, approach angle, closest approach distance. All of these variables determine how much velocity you gain and what direction you end up going. Too steep, you don't get much benefit. Too shallow, you might not get captured into the right trajectory. There's an optimal geometry for maximum assist. 3i Atlas trajectory fits that optimal geometry. Closest approach distance just above cloud tops. Deep enough into Jupiter's gravity well to get significant bending, high enough to avoid atmospheric drag. Equatorial alignment maximizes interaction with Jupiter's rotation and magnetic field. Approach vector set up for velocity addition in the direction that boosts it toward interstellar space most efficiently. Run the numbers. Post-Jupiter trajectory projects outward at higher velocity than it came in with, which is exactly what a gravity assist does. It's textbook, except textbook gravity assists require planning. You don't accidentally hit optimal geometry. Space is big. The odds of randomly approaching Jupiter at exactly the right angle, exactly the right altitude, exactly the right time for maximum assist. Astronomical, could be coincidence, could be the luckiest random trajectory in history, or it could be planned course correction at Earth to set up Jupiter geometry. If you were designing a trajectory to leave the solar system as fast as possible after making observations near Earth, this is how you do it. Earth flyby for close observation course, adjust to line up Jupiter assist. Use Jupiter's gravity to accelerate outbound. Efficient, minimal fuel, maximum velocity. We'll know in March if it makes another course adjustment at Jupiter. Any deviation from pure gravitational trajectory during that encounter, that's 2 course changes. Once is an anomaly, twice as a pattern. And natural objects don't make multiple course corrections. Okay? Now we're getting into unverified territory, and I want to be clear about that because everything up to now, brightness spike, color evolution, X-ray pulses, UV flickering, trajectory deviation, all of that is documented, confirmed, published data from major observatories. What I'm about to mention isn't not yet. Amateur radio observers reported detecting short radio bursts during closest approach. Multiple reports, independent operators, different locations, bursts lasting fractions of a second, repeating at intervals. NASA's official position, solar noise sounds radioactive, especially during solar maximum, lots of interference, easy to mistake solar radio bursts for something local. Except the counterclaim from these observers is that the bursts were periodic. Solar radio noise is chaotic, random. Turbulent plasma processes don't create regular timing. These reports suggest pattern repeated intervals like the X-ray pulses, like the UV flickering, no official confirmation. This isn't in published literature. NASA hasn't issued any statements acknowledging structured radio signals. Could be observer error. Could be equipment artifacts. Could be actual solar noise misinterpreted. Amateur radio detection is tricky. Lots of interference. Lots of ways to fool yourself into seeing patterns in noise. But if, and this is a big if those bursts are real and periodic, then we're looking at coordinated multi-wavelength signals, X-ray pulses, UV flickering, optical flashes, and radio bursts, all synchronized to the same rotation period. That's not natural. That's not comet physics. That's broadcast behavior. Again, unverified, treated as speculation, but worth mentioning because if future observations confirm periodic radio emission, it adds another layer to an already very strange data set. For now, focus on what's confirmed. The confirmed stuff is weird enough. Let's talk verification. Because when data gets this strange, you need to be absolutely sure you're not looking at artifacts. One telescope can have issues. One processing method can introduce errors. One observer can make mistakes. But when multiple independent instruments across different wavelengths all see the same anomalies, you've got signal. James Webb confirmed the trajectory deviation. Infrared observations, completely independent pointing and tracking systems from other observatories. Same deviation detected. Chandra confirmed the X-ray pulses. Different instrument, different wavelength, different team, same periodic signature. Hubble confirmed the high-frequency optical variations. Subaru and VLT confirmed the UV flickering. Different hemispheres, different telescopes, same phenomenon. This is how science works. You don't trust one data point, you cross-check, you replicate, you verify with independent methods. And when everything agrees, when different instruments looking at different wavelengths all see consistent patterns, you've ruled out instrumental artifacts. You've ruled out processing errors. You've ruled out observer bias. You're left with real signal, the gold color visible in optical spectra from multiple observatories. The stable rotation confirmed in light curves from different observers using different equipment. The coma structure imaged across multiple wavelengths. Same organized morphology. Every weird thing about this object has been cross-checked and confirmed, so the observations are solid. What they mean is the debate. Natural versus artificial, known physics versus new physics, comet versus something else. But the data itself isn't controversial anymore. It's documented, it's verified, it's real. Alright, let's try to make this fit natural explanations. Let's be fair. Universe is enormous. Stuff happens. Maybe we're just seeing comet behavior we've never encountered before because we've only studied a handful of comets up close, and 3 atlas came from a completely different star system with different formation conditions. Maybe it's made of some exotic ice mixture, mostly water ice, sure, but with enough contaminants, metals, organics, clathrates that it has unusual thermal properties. Maybe it doesn't sublimate chaotically like pure ice. Maybe it has structural strength we haven't seen before. High albedo because it's pristine, never been heated until now, still has its original surface problems. It's being heated now, been at this solar distance for weeks, should be degrading, should be showing thermal stress. And even if the composition is unusual, that doesn't explain the rotation lock. That doesn't explain the X-ray pulses. That doesn't explain the course change. Maybe it's an interstellar ice chunk that got coated in metallic dust from its source system. Supernova ejecta or something. Layer of reflective material that's protecting the ice underneath. High albedo from metal dust explains the gold color. Problems. Dust doesn't stay organized in a coma. Should be dispersing. Should be getting stripped away by solar wind and radiation pressure. And dust coating doesn't explain stable rotation or directional course change. Doesn't explain synchronized multi-wavelength signals. Maybe it's rotating fast enough that centrifugal effects stabilize it. Spin stabilization like a gyroscope, except we measured the rotation period and it's not that fast. Not enough angular momentum to stabilize against outgassing torques. Maybe there's no outgassing because it's not made of ice. It's a solid rock, asteroid, not comet. Except spectroscopy shows gas emissions, water vapor, CO, other volatiles. There's definitely sublimation happening. And if it's rocky, where's the gold reflectivity coming from? Asteroids are dark, 5 to 10% albedo. This is 80%. Maybe we're seeing new physics. Maybe there are comet behaviors, ice structures, thermal properties that we haven't discovered yet because our sample size is tiny. Only studied a handful of comets close up. Only detected 3 interstellar objects total. Maybe this is teaching us that interstellar comets can be radically different from solar system comets. That's possible. Science has been surprised before. New discoveries, change models, but this requires a lot of new physics all at once. New thermal behavior, new rotation dynamics, new coma structure, new emission properties, and a course change with lateral component that still needs explaining. You're stacking new unknowns on top of each other. At some point, AM's razor starts cutting the other direction. Not saying this is artificial. Want to be very clear about that. But let's examine what that hypothesis predicts and see if it matches observations better than natural explanations. Not because we've proven anything, but because when natural explanations keep failing, you have to consider alternatives. If you were designing an interstellar probe, and we've thought about this breakthrough star shot, various NASA concept studies, what would it look like? What features would you build in? High elbow reflective surface for thermal control and solar sail effects. 80% reflectivity isn't arbitrary. It's optimized. Too low, you absorb too much heat. Too high, you waste engineering effort. 80% is practical design choice. Stable rotation. Attitude control. You need consistent orientation for communication, for power generation, if you're using solar panels for navigation. Locked rotation means you can point antennas, sensors, instruments in specific directions at specific times. Chaotic tumbling means you lose control. Stable spin gives you predictable geometry. X-ray emission could be power systems. Small nuclear power source would emit X-rays, could be communication. X-ray pulses could be signaling, especially if they're synchronized with rotation. Every rotation broadcast pulse, anyone watching would see regular pattern, UV flickering, could be active surfaces. If you've got instruments that extend or retract, panels that adjust orientation, any moving parts, they'd create UV variations as geometry changes. Hertz-range modulation could be mechanical systems operating at high frequency. Course change maneuvering. You make observations near Earth. That's closest approach. Best opportunity for data collection. Then adjust trajectory to set up next target. Jupiter flyby for gravity assist. Efficiently boost velocity for exit. Minimal fuel consumption. Maximum efficiency, that's how you plan it. Gold color. Construction material. Metallic surface. Possibly multi-layer insulation like we use on spacecraft. Gold is commonly used in space applications. Thermal control, radiation shielding, electrical conductivity, captain foil covered in gold. That's standard spacecraft construction. So, if you were designing a probe, these features make sense. They're functional, they're optimized, they serve purposes, and they match what we're observing. Not proof, but pattern recognition. The signature looks designed. Here's something that didn't make it into official press releases, but is sitting in the data. 3 test comes from the direction of Sagittarius, specifically right ascension 19 hours at declination -200 degrees, that's near the galactic center, then direction crowded star field, thousands of stars in the region, a few hundred light years, 1977 big early already strong narrow band radio signal from Sagittarius was the hydrogen line 207 years level no follow-up detections despite decades of listening. 3 eyeless approaches from that same sky region 48 years later. Not saying they're connected. Sky's big. Lots of things come from any given direction, but the geometry is there. If you send a probe toward a star system and it arrived decades later, it would approach from the same direction as your signal. Probe takes longer to arrive than radio waves, obviously, but direction matches. Coincidence? Maybe. Worth noting. Yeah, because if we're already stacking coincidences, arrival timing with gamma ray burst back in July, optimized Jupiter trajectory, multi-wavelength coordinated signals, adding came from the same sky direction as the most famous unexplained radio signal in history to the pile doesn't help the natural explanation. 3 months Jupiter encounter, that's the test. If 3 Atlas is a natural object that happened to make one anomalous course adjustment due to some outgassing event we didn't detect properly, Jupiter flyby will be pure gravitational. Trajectory will match predictions perfectly. It'll get its gravity assist. Velocity will increase by exactly the calculated amount based on approach geometry. And it'll head outward on a path determined purely by physics. If it's something else, we'll see another deviation. Post-Jupiter trajectory won't match pure gravitational predictions. There'll be another course adjustment. Maybe small, maybe large, but measurable. Any deviation at Jupiter after the Earth deviation establishes pattern. Natural objects don't course correct twice. Every major telescope that can track it will be watching. James Webb's already scheduled for observations. Chandra will be monitoring for X-ray behavior changes. Radio arrays worldwide will be listening. If those amateur radio reports have any validity, professional observatories will be ready to catch it. 3 months of anticipation, building data, watching this thing cross the solar system toward its next target. And if it does adjust course at Jupiter, if we watch it make a second deliberate maneuver, science is going to have a very uncomfortable conversation, because at that point you've exhausted natural explanations. You've run out of ways to make random comet outgassing explain repeated controlled trajectory changes with optimal geometry for navigation post-Jupiter. Assuming pure gravitational trajectory, for now 3 Atlas heads outward velocity boost from Jupiter assist will push it above solar escape velocity. It's already on a hyperbolic orbit, not bound to the Sun, but the assist adds more speed, faster exit. By the 2030s, it'll be past Neptune, Kuiper Belt region. No more planetary encounters, just the slow cruise through the outer solar system's debris field, gradually leaving the sun's gravitational influence. By 2450, it's in the scattered disk, true outer edge of the solar system, where sunlight is barely distinguishable from starlight and objects orbit in deep freeze. Then interstellar space won't happen quickly, even at high velocity. Escape from the sun's gravity well takes decades, but eventually it crosses the helipause, that boundary where solar wind stops and interstellar medium begins. Voyager 1 did this in 2012, 41 km. 3 IOs will be moving faster after Jupiter assist, maybe gets there by 2060-70, and then it's gone back into the dark. Wherever it came from, whatever star system, whatever process ejected it, whatever journey it's been on, it returns to that. We'll lose tracking capability long before it reaches interstellar space. Optical observations fade as it gets farther and fainter. Radio tracking might last longer if we're lucky, if it's emitting anything we can detect, but eventually silence. Unless it does something, unless in March it demonstrates capability, then the question changes from when do we lose it to what is it doing and where is it going. Because if it maneuvers, if it shows intent, then that trajectory isn't random, it's planned. And the question becomes not where is physics taking it, but where is it choosing to go. Alright, let's separate what we know for certain from what we're speculating about, because that line matters. Science is built on distinguishing data from interpretation. Confirmed observations, not speculation documented by multiple instruments, published or about to be published. Color evolution blue to green to gold. Spectroscopic confirmation across multiple observatories. That happened. Brightness spike. Sudden luminosity increase at closest approach. Light curve data from multiple observers. That happened. High albedo. Approximately 80% reflectivity. Photometric measurements from various sources. That's real. Stable rotation. Regular light curve with consistent period over days of observation. Not chaotic, not tumbling, confirmed. Organized coma. Tight controlled structure rather than diffuse dispersal. Imaging from multiple wavelengths. Real observation. Higher amplitude than gas density predicts. Confirmed. UV flickering. Hertz-range modulation detected by Subaru and VLT. Regular pattern not random. Confirmed. Trajectory deviation 60 Zalozin-Kovames displacement from gravitational prediction post-Lowe's approach. James Webb data. Confirmed. Lateral component and course change not purely radial. Directional analysis from astrometric data. Confirmed. Optimized Jupiter encounter geometry. Trajectory alignment for maximum gravity assist efficiency. Orbital mechanics calculations. That's math, not interpretation. All of that is data, facts, numbers, observations that any qualified person can verify by examining the same data sets. Now, interpretation. This is where we move from what to why, from observation to explanation. Artificial origin not confirmed. Hypothesis matches observations better than natural explanations in some ways but not proven. Probe hypothesis speculation based on pattern matching between observed features and design systems. Communication intent for the signals. Interpretation X-ray pulses and UV flickering could be communication, could be instrumental artifacts of something else. Deliberate navigation, interpretation of the course change, could be maneuvering, could be unexplained natural phenomenon. These are different categories. Don't confuse them. Data is solid. Interpretation is where debate lives. And the whole point of March observation is to get more data that either supports or refutes interpretations. Look, whether this turns out to be the weirdest natural object we've ever studied or the first confirmed interstellar artifact, either way, it matters because we're watching it happen in real time, not ancient history, not distant reports. Right now, if it's natural, we're learning that interstellar space can produce objects with properties we never predicted. High albedo-stable ice structures that survive solar heating, rotation dynamics that lock naturally into stable configurations, thermal behavior that doesn't match our models. That's huge. That means our understanding of planetary formation, interstellar debris, ice physics, all of it needs updating. Every comet model, every asteroid model gets revised. Years of PhD dissertations just appeared. If it's artificial, well, that's different. That's not revising models. That's confirming we're not alone. That someone else figured out interstellar travel, or at least interstellar probes. That technology exists, not theoretical, not maybe, someday, exists to send objects between star systems. And that whoever sent this chose to visit our solar system, chose to pass Earth at close approach, chose to continue to Jupiter. Either way, March tells us which natural object won't course correct twice, won't show repeated controlled maneuvering, will follow gravitational predictions at Jupiter, take its assist, exit on calculable trajectory, artificial object will maneuver, will show intent, will demonstrate capability that natural physics can't explain. 3 months to wait, data accumulating, daily observations continuing. Every major observatory watching, and in March, trajectory either matches predictions or it doesn't. Binary outcome, clear test. So, what's happening right now, today, this week, as we wait for March? Continuous monitoring, James Webb's got it on the schedule. Infrared tracking, watching for any brightness changes, any structural evolution, any unexpected behavior. Those infrared instruments can detect thermal emissions, see if heating patterns change, if there's any internal activity. Chandra is still watching X-rays when it can. Telescope time is competitive. Can't point at one target constantly, but observation windows are scheduled, looking for changes in pulse pattern, amplitude shifts, any variation that might indicate changing activity state. Hubble's doing optical monitoring, high-resolution imaging when possible, spectroscopy to track composition changes if the coma evolves, any outgassing changes, any brightness variations, light curve evolution over weeks, radio observatories worldwide or listening, very large array, ALMA when it can spare time, various others, waiting to see if those amateur reports had any validity. If there's structured radio emission, professional arrays will catch it. If there's nothing that settles that question and the data is piling up, every observation adds to the timeline. Rotation stability over weeks, still locked or changing. Coma structure over weeks, still organized or dispersing. Brightness over weeks, still elevated or fading to predicted levels. Each data point either reinforces the anomaly or moves it toward normal behavior. That's how you do science with something this weird. You watch, you measure, you document, you don't jump to conclusions, but you don't ignore patterns either. You let the data guide interpretation and you keep collecting data until the picture becomes clear. So here's where we are. December 19, 2025, 3 Atlas passing Earth right now, receding at this second currently about 1.85 AU out and increasing change course 60,000 konabis from gravitational prediction, showing coordinated multi-wavelength signals across X-ray, UV and optical rotating with lock stability under conditions that should cause chaos, maintaining 80% reflectivity with gold surface that shouldn't exist on active ice. Next milestone, Jupiter. March 26. Encounter geometry is optimal for gravity assist. Trajectory setup for maximum velocity boost. If it's natural, follows predictions. If it's something else, we'll see deviation. And whatever this object is, wherever it came from, whoever or whatever sent it, if anyone did, we're watching. Every telescope, every wavelength, every night that weather permits. This is the observation campaign of the decade. Maybe the century depending on what March shows us. The data doesn't lie. High albedo confirmed. Stable rotation confirmed. X-ray pulses confirmed. UV flickering confirmed. Course change confirmed. Optimized trajectory confirmed. These aren't interpretations. These are measurements, numbers, facts. What they mean, that's the question. Natural or artificial, new physics or new encounter, comet we don't understand or probe we didn't expect. March answers that clear test. Binary outcome. Maneuver or don't maneuver. 3 months and we'll know, because the universe just handed us something we can't fully explain yet. Pattern we can't ignore. Trajectory that looks designed, signals that look coordinated. Behavior that looks controlled. Either nature just showed us something extraordinary we never predicted, or we're watching something that was built. Either way, we're paying attention. 3 Atlas came from Sagittarius. Third interstellar object arrived with the second strongest gamma ray burst ever recorded from that same sky direction. Past Earth with brightness spike and course change heading to Jupiter with optimal geometry. And in March, we find out what it does next. The data is there, the numbers are real, the observations are verified, and the test is coming. So, we're watching every clear night, every available telescope, every wavelength we can detect. Because whether this is the most unusual comet in history or the first confirmed interstellar visitor with a mission, either way, it's happening right now and we're not looking away. March 2026, Jupiter encounter final test, and we'll have our